Okay, good afternoon, student. Today we will learn about decomposition in database. So, firstly, what is decomposition? Decomposition is the process of breaking down the function of an organization into progressive greater level of detail. In decomposition, one function is described in greater detail by a set of other supporting functions. In DBMS or in database management system, there are two types of decomposition. First is lossy decomposition, and the second is lossless decomposition. So decomposition in DBMS remove redundancy, and it removes anomalous data and inconsistencies from a database by dividing the table into multiple tables. Decomposition is really important for database to have this feature. And then we will talk about lossless. What is lossless? Lossless means functioning without loss. In other words, it's retain everything. So in decomposition of relation, we have two types of decomposition. First is lossless, and another one is lossy. So we have these two things. Which one is lossless and the other one is lossy? What is lossless? In this slide, we will talk about lossless. Lossless decomposition ensures that no information is lost from the original relation during the composition, and when the sub-relations are joined back, the same relation is obtained that was decomposed. So every decomposition must always lossless. And the other one is lossy. We must avoid this kind of decomposition because we will lose some of our data. So we just need this lossless. A relational table is decomposed or factored into two or more smaller tables in such a way that the designer can capture the precise content of the original table by joining the decomposed part. This is called lossless join, or we can call it non-additive join decomposition. This is the same name. So lossless decomposition is lossless if it is feasible to reconstruct relation R from decomposed table using join. This is the preferred choice. The information will not lose from the relation when decomposed. The join would result of the same. In this slide, we will talk about formal definition. So let R be a relation schema and F be a set of functional dependency on R. And then let them form a decomposition of R. The decomposition is lossless join. Decomposition of R is at least one of the following function dependencies are in a F function, and you can see in this formula. So R1 intersection with R2, the result is R1, and R1 intersection with R2, the result is also R2. So maybe you'll better to see the example about this formula. This one table, it consists of three attributes which are X, Y, and Z, and it consists of real for loop. We will try to decompose this table, and we try to decompose it into two tables. So decomposition is technique of breaking into a relation into several relations. Then after the relation is decomposed, so when it combined again, it must give the same result. not a repeat record or an additional record. If this condition is fulfilled, this is called lossless decomposition. So the result, if we combine it again, it must get the same result. Okay, right now example number 1. We have one table consists of 3 attributes, which are x, y, and z once again. And then we will try to decompose it into 2 tables. When we try to decompose it into 2 tables, the result will be like this. We try to decompose into 2 tables, this. So we have 4 rows, x1, x2, x3, and x4. And we have two tables. This one is table 1, and the other one is table 2. We divide it into 2 attributes in each table. Table 1 consists of x and y attribute, and table 2 consists of y and z attribute. So this one is intersection, this part. This part is the intersection, which are in attribute y, the intersection of table 1. So when we try to combine it again between these 2 tables, table 1 and table 2, so we can we try to get the same result as this first table or this table. Sometimes you can call it universal table. So when you decompose this and turn this into this table, it must give same result. When we try to combine it again, so we get 6 records. This is not 4 again. We get 6 records. So it is different than the first table. Here just 4 records. Why we got this search 6 records? So which is we can combine this x1 10, x1 10, and then z1 into this. And number 1 is x2 20, and then z2 20 and z2 this. And number 3 is x2 20. We have 220 here, 20 with z2 and 20 with z4. So which one? And the other one is x3 30, which z3 is correct. And then the other one is x4 20, once again 20 with z2 and 20 with z4. This. So it turned 6 table. It's when we combine it again, it will turn into 6 rows, not 4 rows. So this one is not work. If we try to decompose this table and we try to decompose into this thing, and after we combine it again, the row result is different than the original result of table. So we can't do that. We must try a different thing. So this table, we can decompose it. We cannot decompose it. So just slide it like this. What if we change the data in each row attribute, one of data? So in this example, we cannot divide this table into 2 tables, because if we try to divide it and really try to recombine it again, it will give different data. It will give more data than the first table, than the original table. So what if we use another data. For example, the table is just same like this. It consists of three attributes x, y, and z. And then but we will try to change the data. We just try to change the data in this part. We'll go in the next slide. So the first table, in the example before, we use this table. In the example right now, we use this table. We try to change Z4 into Z2. So the table consists of three attributes, x, y, and z, and then the row is row 1, 2, 3, 4. Row 1 until 3 in the same data, but in the row 4 we will change it into z2. How to decompose it? So if we try to decompose it, we just take intersection attribute, we choose y, so we choose y here. The first table is x and y, and the second table is y and z. So we can try to we can see in the x attribute we have x1, x2 until x4, and y attribute 10, 20 until 6. And in the table 2 we have this data. What if we try to combine it again? It will give same result, same data result as universal table like this table or not. So we should try it. So in the first row we have x1 10 and then z1. In the second row we have x2 20 and z2. In the third row we have x3 30 and z3. In the fourth row we have x20 and z2. The result, the combined result give same result as original table. So we can decompose this table into two table. So the solution or the conclusion is we must look the data, and then you must see if you try to decompose it and you try to recombine it again, it will give same result or not. If yes, so you can decompose it. If not, so just let it be, just let like this. We can't decompose it if we still use Z4 like this. But in different table with with same structure table, we try to decompose it. We just have this data and we try to decompose it into two tables, and after we combine it again, it return into same. Give you another example. It is about lossless decomposition again. This time we have one table, one universal table that consists of three attributes and three rows. So it is the attribute, the first attribute is name, second attribute is price, and the third attribute is category. So we'll try to divide it into two tables. We try to decompose it into two tables. First time we try to choose attribute name as the intersection. Attribute name as intersection. So we have in the first table. The first table we have we have name and price attribute. And the second table, we have name and category attribute. We can see there is a same attribute in each table. In table 1, we have name attribute, and in table 2 we have name attribute too. So when we try to recombine it again, so we have word first, price is 100. If the name is same word, so the categories is WP. And then, so in the first table, this is table 1, we have word and 100 plus word is WP. In table 2, so the result is word 100 and WP. It is row 1. And row 2, so we have Oracle, we have 1000, and we have DB. This is for row 2. This is row 1, this one is row 2, and what about row 3, number 3? So we have access and 100 and access and database, so the result will access 100 and database will give in row 3. So we have two results here. We can compare it from result below here and here. We can see that it gives same result. It is same. So we can decompose this table. So we can decompose this table into two tables, table 1 and table 2. So after this, I will show you about table with same table, with same structure table, with same attribute, but just different data. In this slide, we will talk about lossy decomposition. This time we have one table with 3 attributes, which are name, price, and category. And then we will try to decompose it again into 2 tables. The intersection of the attributes in here is we use category attribute, use this. So in the table 1, it consists of category and name attribute, and in the table 2 it consists of category and price attribute. So we will try to combine it again in table 1 with between table 1 and table 2. In table 1, word and WP plus 100 and WP. This one is for table 1. And then in table 2, which are Oracle and DB, and then 110 GB. And in row 3 again, which are Oracle and DB, and then 110 DB. Why? Because in this intersection, it is in attribute category we have DB. When we have DB, they consist of 2 data, DB with 1000 and DB with 100. So in this case, we have 2 data, DB with 1000 and DB with 100. In the next rows, for access, DB, access, DB, and then DB again, and 100. And another one is access, DB, DB again, and 1000. We can see here, every DB, they have 2 relations. They have 100 and 1000. This one is 100, this one is 1000. And then we try to recombine it again. After these 2 tables, we combine T1 and plus T2. it will produce 5 rows. And in the original table, we just made 3 rows. So it is a example of lossy decomposition. So you cannot do that. I mean, if you use this table, you can decompose it into this one. For example, you try to decompose it by using category attribute. Category attribute is the intersection from T1 and T2. You use category. So we have here, this one is category, and this one is name, and this one is price. So you try to decompose it into this one, name, category, and price, and we try to compare it again. In this example, it is lossless decomposition. Why it is lossless? Because in the interlace, the same attribute is name, and another attribute here is price. It is for table 1, and for table 2 is category, this one. So if you try to decompose it again, you must have interlace or intersection attribute, and you must choose it wisely. For example, in this time is name, so yeah, for this name, if you use name, all the result is lossless decomposition. But if we try to use like the example before we use category, and then here name, and then here price. For table 1, name and category. For table 2, price and category. The result will give lossy decomposition. Lossy decomposition is when you try to combine these 2 decomposition table into one table again, it will give different result. The data is different. It is more or less. In this case, it is more because in the original table, the result of data is 3 rows, and then in the decomposition table, the result data is 5. So you can't do that. So you must choose wisely between which one the category that you put in this part, this interlace part. That's how the trick. So I think it's enough my tutorial about the composition table, and we will meet again about another tutorial. Thank you very much.